Um, hey guys, my name is Gonzalo, and I usually host the Ethereum Meetup. Today we'll have Guilherme right here to talk to you about the new Python client, which is going to be named Py-EVM, and how you can help him in his team just build it out. And we're also gonna have Celso talking about the token that Pixel created for their hackathon, Pixel Scan. Like how it went, like problems and overall good experiences. Celso, is that no? Okay, yeah. I'll just give a brief introduction. It's just a couple shameless plugs from my team. I don't know if you guys know Consensus. Consensus is a venture studio just focused on Ethereum applications. And I specifically joined Consensus to form the Consensus Diligence team, which we're just dealing with overall security, like audit code, best practices, like mainly a few game theoretical approaches. Just make sure that your models don't actually break and stuff like that. So overall security. And just as an intro, I'll talk to you a bit about how long we've come security-wise, like on Solidity, which is like the main language for the Ethereum world, and how many money was lost and what you could do to prevent that. So yeah, I was supposed to have some swag with me. I was supposed to have some t-shirts to hand out. I don't have, but I promise that I'll make a few quizzes and if you guys send me your addresses, the one who gets it first, I'll ship it over to you. So who can tell me like what happened on June 12th? Do any of you guys know? Yeah, exactly. Yeah. So I'll send you a t-shirt after when I get them. Yeah, exactly. It was the DAO. So on June 12th of the past year, the DAO happened and $160 million were taken out of that specific smart contract. At the time, 160 million were actually they were a lot more representative than they are today. So these were 160 million that were actually 20% of Ethereum's market cap. That's probably why they hard fork, and you don't hard fork now for releasing more of that. And what happened with the DAO is exactly this. It was a re-entry attack. And on a re-entry attack, what you don't want to do is change state before you actually call untrusted code, like other contracts code, right? So these are two separate entities on the blockchain. They reside on different addresses. They have their own storages, and when you change storage before you call it an unknown and untrusted code source, and all of them are interested in this environment, what you have is that after the call, your contract state is actually unknown. This specific example doesn't have any vulnerability because it doesn't actually do anything. It doesn't mask with Ether, but it does not know how to track its own state. Then you have, for example, front running, and front running is another kind of a totally different kind of vulnerability where if you've got the blockchain, you actually have preferences on which transactions get appended to each blocks, right? If you're a miner, you don't actually have to do 51% attacks to be able, like, you actually get the same percentage of hash power that you own of probability of being able to mask with this specific application. And this is what front running does. So if you've got a smart contract that actually relies on transaction ordering for some specific purpose, then you cannot actually be sure that the order will always be correct, right? So you should always check for front running when you depend on transaction ordering. On July 19th, what happened? Do you know this one? Not really. July 19th was the first parity hack. So it was a little bit, it was still 30 millions, but it was a lot less than the other one, right? At this time, 30 million was less than 1% of the market cap, I guess. And what happened was simply a bad visibility modifier. So in Solidity, you actually have modifiers in front of the function definitions, and this is the corpus, the body of the function, and between the brackets and its definition, its method ID, you can actually specify modifiers. And parity was supposed to have visibility modifier right there, saying internal or something like that, and it was actually public because Solidity does public functions by default. So this is also a problem. And then after this one, another thing happened for a whopping 200 million. This time it wasn't. I think that
it's always 1%, right? Less than 1%.
Yeah. Yeah. So this time it wasn't a theft, but it was a lockup, and it is still being discussed, like possible ways to just unlock the funds. But what happened is that the exact same thing, so visibility modifiers, in conjunction with fallback call to a deployed contract by parity, enable this random guy on the internet to just kill the contract. So this was the function that parity was deploying for each client, because it's really small and it saved some gas on deployments, but then they were calling their own one contract that ruled them all, right? So they deployed small contracts for each one of us, but they had this one contract that had a lot of code deployed by their own team, by Parity's team, that had all of the functions that were supposed to be implemented by the wallet. What happened is that when they instantiated their contract, they didn't call the instantiation function that they had there, and this guy just hijacked at the ownership of everybody's wallets, which was actually just one contract, and killed the contract. Locky just sent the money to a random address, and they're now all up.
I don't know if you're going to talk about this, but I would be interested in knowing that, when attacks like these happen, how do you fix a smart contract? How do you fix the problem? What are the strategies to, moving forward?
Totally, yeah. So what they're actually actively talking about this, and I think that the community now, this time around, they're divided in like they're now less on favor of a hard fork, right? Like they were last time for the DAO. So either this is gonna come at a protocol level necessarily. You cannot do anything at an application level.
Okay.
Money is stuck.
And what if I think was it the Ardor that had the front runner attack? I don't know. One of them had a front runner attack. How do you fix a smart contract that rules?
You're
but they did it somehow, so they had to get in touch with the exchange and change the address of the smart contract, or
probably, but that's more forensics than it is actual like solution somehow, right? It's that was probably just, and I don't know specifically of the case you're talking about, but like we in diligence caught a front running bug for the 0x protocol early on, but if we hadn't, this other guy had already, like we got it, they actually fixed it, but on the relayers, because you're not supposed to call the 0x contract yourself.
Right.
And this guy was actually able, he had an Hacker Noon blog post about how to steal money from the 0x contract. So they were fucked. Like if we hadn't got the bug early on, they had nothing to do. Like the guy would actually keep the money, you know?
Okay. But sorry for asking questions.
Don't worry, I'm happy.
This strategy of calling a library.
This is super bad.
It is.
Yeah.
But it sounds good to fix the problem, because if you can change the address of the library, you can fix the problem, right?
Yeah, so a couple of things, but this is my own personal opinion, not like community-wide. First thing, you don't really want gradable contracts. Because like, if you're gonna look at success stories on the blockchain right now, things that actually work and that have users, they're for example Ether Delta, right? They're for example Ether Delta, which at some point, like some months ago, they actually were responsible for like 25% of all the transactions that were happening in the network.
Right.
Do you know how they upgraded their contracts?
No.
It was all on the front end. It was a drop down, like it was an actual drop down on their front end that said, okay, this is our new contract, but you can use our old ones. If you have money stuck on the old one, just go get it and then deposit on our new contract. So it just relayed everything to the front end, because doing this I dislike two things in this approach. The first is that the execution path is much more unreliable. That's why it happened. That's why these two hacks happened. Like it's much more difficult to audit. And then this is the only function in the whole protocol that is not tested on the Geth and Paradise test suite.
Okay.
So yeah, don't do this. Another thing that people do a lot, like it's easy to create faulty VRNGs. So if you're doing a pseudo-random number generator and you use, for example, the block hash for randomness, if you have like an enough big value on your contract, you're gonna get paid. Just the guys that own big ass mining pools, they can actually withhold their blocks and wait for a favorable block hash, so they can gain your contract under that. Also, like, don't rely on the time of execution for randomness, because like game theoretically, also miners can gain timestamps on blocks for upwards of like 12 minutes. So just don't, if you're gonna rely on time, just do it in increments of 30 minutes to an hour. Don't do it on less than that. Then you've got like out of gas attacks. So if you do a big loop or an unbounded loop like this one, and you're requiring that a certain thing happens and you actually revert the transaction, what's going to happen is that if I implement a sufficiently big, well, with Sen, not really. This is actually not a good example, I just noticed now, because Sen has a limited amount of gas forward, but if you forward like all the gas available in your call, then I can make sure that everybody's money gets stuck. This is basically a denial of service in normal InfoSec. And I'm just going to make a couple shameless plugs. So our team has a GitHub repo with this with a much more broad and detailed best practices thing, and also we now have Mithril. Mithril was first built by Bernard Miller. He has since joined the diligence team, and we're working on this. Mithril is a concolic analysis tool, so it's a static analysis tool with symbolic execution.
Solidity?
Yeah, but it's not solidity bound.
Okay.
So it executes on an EVM level. So Bernard is also the creator of Laser Ethereum, which is a symbolic executor built in Python. I can actually demo this. Right, I can just.
Thanks.
Well, I actually see
Some of us are old people. Extra Zoom, please.
Right, sorry. So I was actually running this on an audit that we're doing for AXA. It's as simple as this. So it has a symbolic execution tool that just scans for known vulnerabilities. It scans for all the ones that I talked about. It does a couple more ones. It isn't perfect because like this is not a problem in the contract. It just warns you that there might be an integer in the flow. It's not certain, right? For example, if you see things like this, so this pattern of 256 bits multiplying by an if and accessing a storage slot specifically, when you see this underflow here, where they're subtracting 1, it's not actually an underflow. It's a purposeful underflow. It's just a way to check the length of the storage. So it's not perfect. Yeah, we're getting there. This is added on a newer version, on a newer release that isn't yet tagged on GitHub, but it will be. So yeah, it also does another cool thing, which I also did already, so I can show you, which is it does execution graphs. They're not quite usable yet, but they will be. We're also getting there. Let me just drag it over here. Okay, yeah. So they're not quite usable yet. We're getting there.
I thought you were advocating yoga with that.
Yeah. So Mithril also does this. It's like you can see it's not yet usable, but if you really want to, you can try it.
It's like the whole blockchain. It's not yet usable, right?
Right. Yeah. So there's these couple shameless plugs. Mithril or Smart, our best practices repo, and there's another couple of tools that I actually like. They're built by an awesome team, DevHub's team. I don't know if you've heard of them. They're building DAI, MakerDAO, the stablecoin called DAI, and they have a couple good tools as well. It's called the Py-EVM and the EVM disassembler. Mithril also disassembles, but theirs has a cool feature, which is they mark the stack at each branch point. So we're gonna get there. So if you just stick with Mithril, you're gonna get it all. Do you want to come up now, Guilherme? This is it for me. That's short. I hope it was of some help.
Which adapter do you have there?
What do you need?
West PC.
What do you need?
I have the same Firewire. Is that name?
Firewire.
No, it's not.
VGA.
No, not VGA. It's the Mac used to use it.
Oh, I have
the display port. Is it display?
Yeah, I have. But it's VGA. No, I have not.
I have one. Just wait a second.
I actually had it. Is that? I think I've done upgrade. Yeah.
But it's the VGA. Yeah. Yeah.
Well, I don't have much to do anyway, so
Maybe so.
I don't have slides anyway. I can. It's just something that I was gonna demo in the end.
Maybe it's Celso.
First wait, yeah.
But yeah, we're also doing a couple things in Python.
Yeah, I didn't know about that.
Yeah, it's cool though. I'm just starting to help Bernard. There are a couple of things that are still not working.
that Linux?
Yeah.
Which of the 10 flavors of Linux is this one? Where's the screen definition? So 20 years past mine, it's pretty much the
Yeah, you
same.
still have to.
But it's next year.
It's next year,
The
right?
next year is the year when.
Exactly.
I think I still don't offer
2018.
the
That's the
x86
one.
one.
I think that's about like the last time we did that was the last time we used a projector in this thing. There used to be a display.
Any Linux engineer?
No, someone showing me the desktop. Hasn't recognized.
Oh, really? I think I have another one.
No, don't worry.
Can you use mine?
Well, it's just like if you can install the.
If Celso doesn't find that, he's going to try it.
Take two. Something is happening. You got it?
Where is it on stage?
I don't know. This is just one of the standard.
That's actually nice one. That's the. I'm pretty sure it's nice.
So other than my laptop, which doesn't work very well, as you can see, that like what I'm here to present today doesn't really work very well. It's still like in development. It's still experimental technology. So my name is Guilherme. I work with Gonzalo for Consensus. And I got involved in Ethereum like earlier this year, so I'm still like a newcomer as well. Like I'm not that much experienced, and I've been working on several different Ethereum clients. I haven't worked on Ethereum applications. I'm working more on the platform. And one of my first tasks was to try and get the existing Ethereum Python client to sync with the mainnet. I did plenty of work on that, but that code base is a bit has been around for a long time. It's one of the original implementations of Ethereum. Has lots of things, experiments that they did there and kind of abandoned. So the code base was a bit messy. It wasn't syncing with mainnet. It wasn't being actively maintained. There was a lot of effort put into it, and we made it better. But still, at some point, this guy, Piper Marion, came around and decided to start something from scratch, a new implementation of Ethereum in Python as well, with some goals, like try and make it. So the main goals he had was he wanted it to have really good documentation for the developers, so that developers can easily understand what are the APIs and how to use them. It had to be like really extensible and modular, so that people can build new, like fork, experiment with different ideas. What else? And it had to have good, like a clearly defined deprecation strategy, so that when we deprecate APIs, It's clear for the developers what steps they need to take to upgrade and how much longer they can rely on the old APIs. So basically, we do not have any of those in the old Py-EVM, and that's why Piper started this new project. So we've been working on this for several months now. Now we have just finished the implementation of the peer-to-peer networking layer, like just the very basics of it. So now we have a light client. It's still not syncing all the blocks, all the transactions, all the information. Right now it only syncs the headers automatically, and then it can fetch extra information on demand. So this is the protocol that was developed for light clients. Light clients are to use like in embedded systems or like mobile phones, devices which have limited resources or limited bandwidth. So yeah, so this is basically the state we're at. Currently, we have it can connect to the mainnet or testnet, any of the blockchains, and sync headers and fetch extra data on demand. We're trying really hard to write lots of unit tests for it. So it's really all the code is pretty well tested. We have really good test coverage, and we follow like all the software engineering best practices. We have really good documentation. We refactor very often when we see opportunities for that. So we want to make this a code base which the Ethereum community can experiment with, but we also want to make it stable enough so that people can use it on a day-to-day basis. A few weeks ago, there's been the research team for the Ethereum Foundation. They started developing the sharding fork in Py-EVM as well. They're still like on very early stages, but yeah, there's something else that is happening there.
Are you making the consensus algorithms modular as well?
Yeah, we have. This is one of the things that Hyper did in the very beginning. Is like how he modularized all the forks rules. So when there's a new fork, it's very easy. You just have to specify the new opcodes or the opcodes, the changes between one to the next. So you inherit everything from the existing one, and then you modify whatever you want. So just search one or two files, and you have.
Do you have different repos for the engine, for example? Like, could you try to use your thing in Meetup? Like, for a symbolic execution? Like, instead of syncing to the mainnet, maybe just running our own outputs, like in a pipe fashion? We could somehow pipe the outputs there. Like, just pretend we have our contract on some testnet.
You should be able to, because like this is still like, we want to have, as I say, clearly defined public and private API, so you can use that as a library. You can import it. We have a VM class which provides all the opcodes and executes the transaction, so you could possibly import that from your Python code. But at this point, it's still like very early stages, so things are still in flux. We don't know exactly what is going to be public and what is going to be private. So it's all well documented. We have log streams, we generate documentation for all the APIs. But still, like, we can work it out, but it might change and we might break there. So.
Cool.
So yeah, and also, so part of the peer-to-peer networking code is the node discovery protocol, which, in order to connect it, you need to talk to several nodes in the network to figure out which ones are you should connect to, because there are like too many. There's testnet, Wrinkle-B, all the Rocksten, and all different blockchains working, and they all have different. They're all different blockchains, and you only want to connect to the node. You can only connect to the nodes on the same blockchain as you. and finding those ones is a bit problematic. It's okay if you're running a full node, because most of them are full nodes as well, so they talk the ETH protocol. If you're a light client, a light node, you need to find the ones that serve light clients, and there are few of those in the network. So using the node discovery protocol to find those, the existing node discovery protocol is like looking for a needle in a haystack, because there's very few of them, and like you first have to look for nodes, you connect to them, you do the initial handshake, and only after that you realize, oh, this is a node which is in a different blockchain. So you wasted all those round trips before you realize, oh, I shouldn't be talking to this node, there's no point. So now they're developing the version 5 of the node discovery protocol, but it's like still experimental. There's no specification, there's only the GAF implementation for it. And yeah, I had to like kind of reverse engineer that. We have some of it in Py-EVM. It works, but it's still not very reliable because it's like there's no specification. I had to kind of reverse engineer that, and it's not on our master branch yet. It's on a separate branch. What else? So yeah, we're aiming for, we plan to have like an alpha release soon. Right now, if you go to our on the GitHub repo, we have already there's some documentation. There's instructions on how to install it and how to develop documentation. Does anybody know the Wi-Fi password? Oh, okay. The guest or is it guest bed? So yeah, that's basically the current state of Py-EVM, and I think it's a really good starting point if you want to learn more about how Ethereum works, because it's a very like young code base still. It's very easy to navigate, find your way around. We have there's the Gitter channel. So here you can go there, ask for help if you need anything. There's several issues, GitHub issues tagged with there's a good first issue label. So those are issues that are like for new developers who want to get involved. Those are really good candidates. Yeah, now I can show you. And right now, it's a bit boring. There's not much to show. So but I guess I can show you like the quick start. You can run like an interactive shell where you can see the headers being synced, and you can use that to fetch extra information that is not fetched automatically. So.
I'm just gonna do another shameless plug and say that we now have Gitcoin on consensus. Maybe we can get some. If you guys need some.
I actually had that on my notes.
Really?
We had sometimes there was just like a few days ago there was a bounty from Gitcoin. So yeah, sometimes there are bounties on some of those issues. So yeah, you might get an Ether reward if you fix one of them.
Yeah, I forgot to say about our own repo as well.
You have that
If
too.
you- Yeah, if you go to the smart contract, if you go to the best practices repo, sometimes you'll get like, you haven't had like big bounties, but we've had like 0.2, 0.3, 0.5 Ether for like just some of them are a little bit harder, some of them are a little bit easier.
Yeah.
But you can just check it out and you can win like $500 like at a time. So just
Can you pay us in Bitcoin Cash?
not yet. Not
Just
yet.
teasing, just
So here I already have like a development environment. This is, yeah, this branch has a fix. The branch I haven't pushed it yet, but the one that is the master one on GitHub currently has a bug which I just fixed. So if you try this right now, it won't work, but it should work. I'm gonna start from scratch here. I'm gonna use an empty database, so it's gonna start syncing. This by default it runs on the testnet. You can switch it to run on mainnet if you want. So this. If it works, it should start syncing all the headers from the Genesis block until like it won't stop. It will only stop once it reaches the current latest head. So, oops. What? So yeah, as you can see there, it's syncing. I'm gonna stop that. So you see, it was connected to a few peers and syncing, fetching that information from those peers. So I'll just restart to show like the beginning, how it connects to the peers.
Okay, so you don't actually need to run a Git on your...
No, I'm not running that, no. This is like, it's connected to peers that are nodes that are out there in the network. And then here you have, so the only thing it gives you here is this chain object right now, which is it contains just the headers. So I can get the canonical head. So current, like right now it's 19.8.16, which we just went past that. So if I do it again, I'm gonna get the other one. And so this is the information it syncs automatically. If you want something else, like a block, then we have methods for that as well. Get so that's
Do you fetch blocks on demand from other peers?
from those peers I'm connected to. Yeah, one of them. Right now it just picks the one which announced the latest head, so the most freshest peer.
Yeah.
So let's get the block for that header 22439. So. But so since this is on demand, it's gonna do an asynchronous operation. So you see this one here, get canonical head. We already have all the headers, so that is synchronous. So it just fetches the header from the database. Now, when we want to get the block or anything else, it's an asynchronous operation. So we need to use this helper here, which only exists on this interactive shell. And yes, as you see. So block 22439 is like, this is what I was saying. So we have different classes for all the forks. So this is a frontier block from the frontier fork. So now, which block are we at? We'll call it still frontier. So let's get current head. Yeah, still frontier block. But if I do like which block number can I connect? Something really.
It will be like Metropolis or.
Oh, because we don't know about that block. So
Which testnet is this?
Robson.
It's
Robson. Yeah, it's Robson.
Yeah, I'd say, so you would classify the block as being one of the most hard for rules.
Yeah, and then it changes
Right.
the class. So blocks, right now you can fetch blocks on demand, and you can, this is still a work in progress. One of the things that we have in the light client protocol is Merkle proofs. So when we want to fetch anything from the state, we don't fetch the whole state because it's huge. Where we fetch, we ask a node for a proof of a given key. So, and then it sends us the tree path, all the nodes on the path to the key we want. And we can validate that proof because we use that every node is the hash of its child, so we can make sure that information is valid and that is what we expect it to be. But that's still a work in progress. It's not really working. But yeah, with that, we're going to be able to fetch state information as well.
You guys plan to integrate like all the methods that all the other clients support?
Yeah, well, right now there's one guy who's just started working on the RPC server, so which he's adding all the methods,
Cool.
all the RPC API methods, yeah, the JSON RPC methods. But that's only going to be useful really once we have a full node where we are syncing the full, all the information, the full state and transaction. That's probably what I'm gonna work next. But yeah, this is basically to say like there's lots of interesting stuff here, lots of interesting areas to work on. It's a good opportunity to learn as well because, as I said, it's a new code base and it's easy to navigate and it's still small. So if you
So is that going time? Is that going to be the official VM?
You see, that's one problem that we are aware of. Python, it's not a very performant language, and but we don't expect it ever to compare performance-wise with Geth or Parity. But we should be able definitely to sync the whole blockchain and process the whole blockchain. But I think the real goal is, I think this is just my opinion. It's not like I think nobody really knows how it's gonna evolve, but the goal is for this to be like for research and people to experiment, because Python is a very expressive language. It's very you can develop, you can be
It's
really
much more easy to develop
and that's why the Foundation's research team is now doing their research on Py-EVM. They're starting to switch now. Before they were using Py-Ethereum, but as I say, it's really complicated to do stuff there because of the state of the world there. So they're moving over to Py-EVM.
And you're being funded by Consensus or the Ethereum Foundation?
Well, I work for Consensus, but I'm kind of on loan to the Ethereum. I work more closely with the Ethereum Foundation folks than with Consensus because the lead developer for Py-EVM, he used to work for Consensus, but he moved. Is now working for the Ethereum Foundation. So yeah, it's a bit of both. Like Consensus, of course, has interest in this as well. Like Consensus wants like the whole ecosystem to thrive, to be successful. So it's in their interest.
Yeah, I can see this being really, really cool for guys that have Raspberry Pis at home. But if I just want to do like, you guys should support like doing your own private network. If I just want to spawn like a network in my home or something like that, it would be really cool.
Yeah. And
so could I use this for something like what we've done at Pixelscan?
Probably, yeah. Do you guys support like doing your own testnet? Like spinning up like a different network at least?
it should be really easy.
Right.
It should be really straightforward to do that. And this is one of the reasons why I started working on Py-Ethereum is because the enterprise Ethereum alliance, they want some like a base for them to do their experiments to see, and they were thinking of using Py-Ethereum, but it turned out that it was not really a good choice. This might be a good choice for them as well in the future, Because if you're not running a public blockchain, if you're not processing like thousands of transactions a second, then Python's performance is great. Like you don't need to worry about it. It's only after you cross a certain threshold that becomes a problem. So I guess that's it. If you guys have any questions, or
have you tested this with other interpreters besides CPython? Have you tested it with PyPy?
there was some. I don't think they did. I think somebody tried, but they didn't match.
You're using async, so you're using async IO. So
Yeah, I'm using async IO.
So you're going to need PyPy speed to become stable anytime soon.
I would need, sorry?
To have PyPy feed become stable anytime soon. It's going to take at least 6 months.
So this is another thing. So we're using async IO, which is something from Python 3.4. It was introduced in 3.4. I think it's much better than the usual callback mechanisms. It's still not perfect, but it's a good step. And yeah, it's now at least there is a standard for async network communication for concurrent programming and Python. So
Language wars.
yeah.
Thank you. Yeah.
My pleasure.
So I'm next.
Yeah, I guess so.
I guess.
No one there.
I'm feeling a little nervous because I know nothing about 3K. Now with my guys after. I can sense your jokes.
He started it.
It's fine. It's gonna be fine. Yeah. Okay, so no. So should be no. Cool. This is dangerous. Okay, cool. So, this is it. No. Almost there. Okay, so while I try to... Okay.
You can click on the dinosaur to use it.
Shut up, dude. Cool. So Gonzalo kindly asked me to take the opportunity and talk to you about something we've done last year on PixelScan. I don't know if
This year.
any of you this year, right? So how many of you know what PixelScan is? Okay, 5 people. Cool. So for those who don't know, PixelScan is the largest, the biggest, and the better hackathon in Portugal. It's also a conference, so lots of content. So if you haven't been there, make sure to be next year. We do it in around September every year, 3 days non-stop, 1,000 developers. It's pretty cool. And you know, every year we try to do something different and something fun. And this year, because you know, blockchain and hype and everybody's talking about it, and we wanted to learn about the technology, so we've decided to do something fun around blockchain and the hackathon. And one of the problems that we always had at PixelScan, and just so you know, we've organized the event for 10 years, was the whole mechanism for voting the best projects. I mean, it's always been a mess, you know. We've used pretty much, right? So, and we really wanted to fix that problem, and so we basically came up with a solution using Ethereum and creating a special coin, a special token, in order to allow participants to vote in their projects and you know the projects that they wanted to win. So we basically created so I'm going to try and explain what we did. I'm not a very low level Ethereum developer. I've had a lot of help from my team as well, but I think I can explain to you what we've done, and if you have questions, make sure to interrupt me and ask them. So what we did is we created a private network. We actually did that on Azure, Microsoft Azure. It was pretty quick because they have a point and click. I have some from Microsoft.
Sure. Okay, so there's a marketplace offering where you deploy an entire test network with a click. So it's a whole shebang.
Yeah. Private network. We had 2 nodes mining the network, completely private. Nobody could mine the network except us for reasons. We've also put up together 2 explorers. One for ERC20 tokens and another one for normal blocks. And we've created this special token, actually an ERC20 compatible token and a smart contract that allows us to issue tokens to the PixelScam participants. The token was called Exposure, and the reason for that was that we got inspiration from the oatmeal cartoon. If you don't know the oatmeal, make sure to look into it. It's a very funny guy. So this is the life of a designer, basically. And so we've created the token and we created a market around the token, okay? And in order to create the market, we had to came up with a rule set of incentives in order for the market to be liquid, in order for everybody to have some kind of incentive to use the tokens, either being a participant or a project owner or an angel. I'm going to explain what an angel is for you, or anyone using the market would have to have an incentive to use their tokens. And I don't know if you know this, but I'm also not an expert on market theory or game theory or Nash equilibrium, but it's really hard to find the right incentives in order for the market to work and to be liquid. And if you get it wrong, you can actually destroy the whole dynamics, and the market just doesn't work. So one of the things that we were afraid of when we started looking into this idea is that by not doing a lot of simulations because we were out of time, we could have the wrong set of incentives and the market wouldn't work. But surprise, I think it worked pretty good for the most part. And so I'm going to tell you the story. So this is the way the participants could earn tokens, and we actually connected the issuing of tokens, not the issuing, but because the tokens were also pre-mined, so they were all issued when we've deployed the smart contract. But a participant would get tokens from us if he did something at PixelScam. So we connected that with the badges system that we had in place. We've already had a gamification strategy for PixelScam. So for instance, if you registered for a project or if you did some social media around PixelScam, or we had a number of things that if you would do them at PixelScam, you would earn badges. So the rule that we set was that if you earn the badge, you would earn tokens, and you began to accumulate tokens in your wallet at PixelScan. So ways to earn tokens: participating and earning badges, convincing other participants to send you money. So I could actually transfer my tokens to my friend. We allowed this, obviously, because the blockchain was there, so anybody could do it. Convincing angels to invest in your project. I'm going to tell you something about this later. We've also created a marketplace in which you could provide services to the participants, and you could advertise your service. And by providing your service to other participants, they would pay you with tokens, so you could earn more tokens. And this was also a fun part, by solving a very special scavenger hunt that we've built on the PixelScan t-shirts. So we've had a special quiz in which you would have to find a private key that was hidden on the t-shirts of PixelScan. It wasn't easy, but by the second night, and a lot of hacking, social hacking as well, actually Kevin was the first guy to discover the private key, so he won a lot of tokens with that. And then you could spend the tokens by voting in projects, or by buying services on the marketplace, or by giving them away to other participants. Okay, and these are the rules that we set for the market. So each badge would give you 200 exposures. You could transfer or accumulate. You could buy services. We've had about 20 angels in the event. So the angels were special people that we would invite to be part of the jury, and they would have 25,000 exposure tokens to invest. What else? Set of rules that you had to be aware in order to win the project. Okay. This is a simulation. This is the formula. So we've made sure to make everything very transparent to the participants. But if you didn't trust us, you could always go to the blockchain and see what was happening there. One of the interesting parts about this is that, even if everything went south, and there was a big chance that that would happen, you could always go to the blockchain and see exactly what happened, and we were completely transparent about it. So I don't think anybody could blame us for things go wrong. What else did we do? We've created a special wallet for the event. This is actually a MyEther wallet instance, painted with some special CSS, but it's their code. We've just cloned it from their GitHub, and you could use this to manage your private key, your wallet, and transfer your tokens. Or if you wanted, you could use MetaMask or any Ethereum wallet to manage your tokens. You would just need to connect it to the private blockchain that we've built. We've had a block explorer. We've got a ERC20 Explorer as well, specially configured to recognize our token. We've built a GitHub of scripts and formulas that you could use if you wanted to use your wallet or your tokens programmatically. You could also use that. Some tech information, etc. Then let me show you something else. This is the projects. So what happens with the project? So we've built this support website in which we try to replicate the Kickstarter image And so if you wanted to build a project for PixelScan, you would actually start a campaign, okay? So you would have to register, fill out a web form with the project that you were submitting for the hackathon, tell us who the team was, okay? And then when you publish your project, we would give you a Ethereum address, and anybody could use this address to send money to you. So the metaphor is that your project would be a campaign within PixelScan, and you would need to publicize it and ask angels and investors to put money in your project. And in the end, the winning projects will be those that have more tokens. Okay? Those would be the winning projects. So you can see that there's something wrong with the private network, because you should be seeing the number of tokens in the corner there, but for some reason it's not working. But also one of the things that's working is the MetaMask integration. I'm not going to put my password in here, but it's also working with the MetaMask wallet. So, you know, from the beginning that projects began to appear, everybody started using the market, tokens began to appear on the projects. You could see, you could actually see those that had more exposure. These were actually the winning projects, okay? And we think the market worked quite well, very dynamic. Everybody used I'd say more than 80% of the participants used the market. And in the end, the winning projects were actually the better projects and those that put more effort in building that. These are the angels. So these are special people that we invited. And they had more tokens than most. This is the market. So on the market, you could create a service in the event, and you would sell your service to the participants. So so you can see that there's something like you know, pretty funny stuff like. Like my life. Hugs, okay? If you need a hug, you would have to pay me 30 exposures. Absolutely nothing, one exposure, logo design, etc., etc. So a lot of people use the market as well. That's it. So, end of story. The market worked, the rules were fair, everybody felt an incentive to use their tokens, either being angels, participants, or project owners. There was a balance between power. Even if the angels would vote on a project, the people and the participants would have a lot of tokens to you know, challenge that decision and influence the end result. The feedback was very positive. We've learned a lot on Ethereum and blockchain and smart contracts while we've built this, and it also allowed PixelScan participants to get into blockchain and, you know, learn about private keys, Solidity, smart contracts, Ethereum, etc. So I think it was a lot of fun. It was an experiment. Maybe next year we'll put it on the mainnet. Who knows? But probably not. But yeah, I don't know if you have questions.
About t-shirts.
Oh, the t-shirts, right. So I can actually tell you what we've done with the t-shirts. Let me see if I have an image here. I do. So this can be fun. Just give me a minute. Ask another question while I...
On the technical point of view, were you using some blockchain that was all done?
Ticketing.
And
Did you say ticketing?
or were you creating something from scratch?
Did you say ticketing?
The machine behind all this.
The blockchain, I think. Blockchain, right? It was a private one.
Ah,
They had their own private blockchain.
okay. But it was created from
What
scratch
version of
or
the
using what is on internet.
We've reused a lot of things. So the blockchain was a private network based on Ethereum. We basically had, I think, 3 get nodes running and mining the blockchain. Mining very quickly because we wanted this to work. For the smart contract, we've based the smart contract on a template by consensus, actually, because it was tested. We were afraid that we would introduce some kind of bug, and then it would be a problem. We would have a big problem on the event because, code rules and blockchain. And we also had a lot of hackers in residence, so yeah. The explorers and the wallet were all based on open source projects on GitHub, so we didn't develop those. What we had to develop were the scripts and bots and daemons that we had running on the background, doing all the distribution of tokens based on the badges system and some other fun things. We've also connected the daemon with the community Slack, so everybody could see who were winning badges and exposure tokens. Everything was public. So, but our work was mostly setting the rules, gluing everything together, and testing, making sure that it worked, and doing support to the participants. You can do a lot of stuff with what's online on GitHub, Ethereum, consensus. But I think that one of the rules is do not reinvent the wheel. Yeah.
We actually audit that repo that you guys use, so that's maintained by Village.
Oh really? Was it good?
Yeah, we hope so.
Okay, let me see if I can find the t-shirts.
Next year you gotta do some crypto kitties for Pixel Scan.
We will, and we'll probably use Py-EVM.
Hopefully we'll be ready by then.
Cool. So Pixel Scan, where's the t-shirts? T-shirts.
Next year we'll do an even newer token model, and we'll get some outside money to bet on.
I have a snapshot of the final T-shirt and the snapshot of the final Google sheet where people tried to solve the puzzle if you want.
Yeah. Okay. So this will do it. Okay. So this was fun. We always offer T-shirts at PixelScan to all the participants, and so this year we've done 24 T-shirts.
Yep.
So let me see if I remember everything. Yeah. Okay. There we go. So the goal here would be. I mean, nobody knew this. They had to find this out. But the goal would be to, on the T-shirts, there's a way to find a private key, to calculate the private key. And when you have that private key, you would use it to get access to a wallet inside a private network. And by opening the wallet, you would have 50,000 tokens that you could basically use, right? And the first guy to crack the code would get access to the key and would get access to the tokens, right? The hard part is to find, first of all, that there's a private key in here, and then how to crack it, okay? So there's 24 T-shirts, and there's a small code, if you see it here, on each of the T-shirts. So this one has a code. This one has a code. Yeah. This one has a code, etc., etc., etc. Okay? So how does this work? This is basically very simple. This is, I don't know if you all know how a blockchain works. Probably yes, but you know the blocks are glued together by a hashing function. It's an SHA-256 hash function, and that's what's used to glue the blocks together. So this is basically part of the full hash. I mean, the full length of the hash wouldn't fit in the t-shirt, but you don't need that. This is quite secure, and so you can see this as an hash, okay? And if you look at the blockchain, the hash of the next block is the result of the data in that block and the hash from the previous block, okay? And so, if you get all the hashes from all the t-shirts, you would need to find the correct order of the t-shirts, basically, and you would need to figure out that this hash is the result of the hashing of this particular t-shirt and the hash from the previous t-shirt. Okay. Mm-hmm. And when you get access to, when you find the right order of all the hashes, then you would need to do something else. And this is the fun part. If you notice the text of the t-shirt, there's always one of the words that is highlighted. Okay? So in this t-shirt, the word is right. This t-shirt, the word is fire. Okay? And this t-shirt, the word is silly, okay? And this seems completely, design stuff, aesthetic stuff, but it's not. This is an important word. When you find the right order of the t-shirts, you would need to build you would need to use the words in the t-shirts, and you would have I don't know if you know this protocol, it's something called BIP39. Okay. Do you know what BIP39 is? It's a way to use a text mnemonic to calculate the private key. A private key of the a private key, basically. You can use it with Bitcoin or Ethereum or any blockchain actually. So and the mnemonic is basically 24 words that need to be in the correct order, and you would just input that 24 words into the algorithm that calculates the private key, and you would have the private key and you can use it. So the challenge would be to find first the correct order of the t-shirts, second, extract the word in the text, third, take the full mnemonic, run it through the BIP39 algorithm and get the private key, go to the blockchain and get the tokens. So the team took 2 days to find this, and Kevin was the first one to find it, to crack it. And the only reason why it took so long is because the first thing the participants did was to look for all the t-shirts. So they had to go through all the tables and all the participants and find all the different t-shirts they could get. But they made a collaborative spreadsheet on Google with all the t-shirts they found. But they made one tiny mistake in the third t-shirt. The hash was wrong. Okay? And when you get one of the hashes wrong, then all the hashes after that t-shirt are completely wrong because everything's hashed with the previous blocks, So that's a big problem. And it was one of the first t-shirts. So everything was completely wrong for a lot of time and nobody could figure out what was wrong. So actually we came in, looked at the spreadsheet, and we gave a hint to the group that was trying to crack the code. And they found that the third t-shirt was wrong, they fixed it, and in 1 hour they found the private key, and it was a lot of fun.
I have a copy of the spreadsheet if you want.
Yeah, sure.
I just
For
sent you the link.
historical purposes.
No, it's not an address. Hang on, you can send it from via message to you.
Oh, and by the way, if we had to print the t-shirts, so we had to test everything, keep it in secret between 3 or 4 people. If we made a mistake while printing the t-shirts, we would mess the whole quiz. So it was also fun in terms of testing everything and making sure that we didn't screw up. But it worked. I think it was fun. I'm done. Questions? Cool. Thanks.
What do you mention? How did you find the first T-shirt at the beginning of the book?
Yeah. So yeah, sure. So the first T-shirt was the hash of the words of the T-shirt. So that was one of the hints that you would need to figure out, but it was easy. And then you would know that there was a relationship between the highlighted word and the code that was, below the T-shirt. And you would quickly figure out that that was a hash of the word. Okay. Then on the second T-shirt, you would need to find that would be the result of the same thing and the previous hash. And if you figure that out, then we would easily know that there was a chain of T-shirts, and then it would be just social work. Okay, cool.